Hi everyone, welcome back to BIMKLUE Revit tutorial. Today I'm going to show you a simple steps on pump assembly. Okay, basically I will show you how to assembly your pumps with all the pipe accessories together to set up it as a functional equipment for your model. Okay, so it consists of a few components, of course the pump itself and pipe accessories and the fittings. Okay, so let's start step by step. So I won't go into deep on how to model all the pumps one by one and fittings one by one. Yeah. So if you want to know more, you can of course enroll to my course here on bimklue.teachable.com, where you can have all the step-by-step tutorials starting from beginning, which is a scratch from the project, basically nothing. Then you will build your own equipment, pipe accessories, piping, fittings, pipe systems until the completion of the whole project. Yeah, so don't worry, we will guide you step by step throughout all this tutorial over here, 27 topics, and just cost about 300 USD. Okay, so don't worry about our course because we have a good reviews from the students around the world. Yeah, so basically they've given us a very good rating for our course. Okay, so come back to the topic today. I will show you the first one here. So I'm going to model another set of pump here. Okay, so first of all I'm going to click on the floor. Of course, talking about pump, we worry about the vibration, so we need a concrete plane. So concrete plane basically is raised up of concrete, a piece of concrete. Yeah, so your pump won't directly mount on the floor structure and transit the vibration to the structure and eventually damage your structure floor. Okay, so the function of plane is like this. Okay, so what is this? Basically is a piece of concrete. Okay, so next, if you want to absorb more on your vibration, you need an inertial block. Okay, so if you want to know what is the inertial block, basically is another piece of concrete which is casted into a steel bracket and with a spring isolation. So when your pump is running, so the vibration will be absorbed by this spring isolator instead of transfer it to your structure element. Okay, so this is how you mount your pump, basically sit on the inertial block here. Okay, so come to here. So we have an inertial block, so we place it on here, system, then we go to here, click on model, click on component, then we find your inertial block. Yeah, then just put it up to here. Okay, of course you need to press space bar, is the rotation of your family. Okay, so here, due to the time constraint, I have my inertial block ready. So if you want to know how to model this inertial block, of course you can, as I said, enroll to our course. I will show you detailed step by step how to do it. Okay, so here another one. Okay, looks like this. We need to pull it longer. Okay, so how to do it? Because I already include the parameters into this inertial block, so you can modify the dimension of the inertial block. Okay, so here next one, I need to put a pump. Let's say I want to have a 8025H pump, which is 60 horsepower pump. Okay, so come to here again, we go to system tab, then we go to the model, then click on component, then we have a pump. Okay, let's say I'm going to use this pump over here. Okay, just place a simple pump here as a demonstration, place on the inertial block. Yeah, so we have double protection. So normally most of the project won't use inertial block. Of course, if you want more sensitive on the vibration tolerance, then you need a inertial block here. Okay, so now it's done. Then next one, of course, if you want to model a pump, you need to have a connectors, one in and one out. Yeah, so this is basically is an end suction pump. Okay, If you want to see 3D here, I'm going to 3D. Okay, I expand it another few meters. So this is my new set of pump here. Okay, this is the end suction pump. So how's the end suction pump function? You can go to Google, then you can search what is end suction pump. Then basically we have a motor that mount on the pump propeller here. Then when the motor is spinning, then you will suck the water, go into the inlet here, then push it out from here. Okay, this is the outlet. Okay, so next, go back to our section view over here. Then we draw a pipe out. Just draw a pipe out will do. Then drag a little bit. So this is the outlet. Yeah, just draw a pipe here out to where? Then I'm going to leave it first. Okay, so next I have a 200 mm pipe inlet. Yeah, then I have 150 outlets. Basically the suction has to be one size bigger than the outlet. Yeah, this is a requirement for the fire pump system. Okay, so next one, I need another vibration isolation device that I don't want to transfer my vibration of the pumps to my pumping system to loosen all the parts and fittings of the piping. Okay, so next I need this one. I'm going to show you this. This is basically is a flexible joint of the pump. Yeah, so flexible expansion joint. Okay, basically is a flange with a rubber connection. Okay, so go back to the section view here. Then PA is the pipe accessories. PA is a pipe accessories shortcut key. Yeah? So I search the joint, flexible joint. Okay, I have 200 mm. So I place it over here. So basically it will automatically go into my piping system. Yeah. So PA again, I have 150 mm expansion joint. I put it over here. Okay, so the vibration won't transfer from the pump, won't transfer to my piping system. Next one, of course, the suction side I need some sort like filter, so I need a strainer. So PA again is shortcut key for pipe accessories. If you don't want to use the pipe accessory, the shortcut key, you can go to the system tab here. So you find your piping, then you can have your pipe accessories icon over here. Okay, click on here, also bring you to the pipe accessories library. Okay, so I need a strainer. Okay, 200 mm strainer will do. Okay, click on here. Then if the water coming in to here, then it will trap all the small stones into this device here. Okay, so if you want to service, then you just open this flange to clean out all the small stones that possibly damage your propeller. Yeah. So from this picture here is more easy to explain. Yeah, this basically the water going through here, then will flow into this basket here, then you flow out. So all the particles, stones will go through and filtered here, then go out to your pump. So it won't damage your pump propeller. Okay. Next one, of course, you need a gate valve that if you want to stop the water and you want to carry out services to the system, then you need to stop your water. PA again to access your pipe fittings, then you need a gate valve here. So 200 mm gate valve, just put here so you can shut down the water supply. Okay, next one. So after that, you don't want the water to be backflow inside to your pump. Yeah, so you need a check WAF. Okay, PA again, PA to access your pipe accessories. I search my check WAF. So this is a check WAF here. So I just mount into here. Okay, of course you can rotate. Yeah. Check. This is a check WAF. Okay. So how check WAF function? So if water flow into this direction, of course the flap will be open. Okay, to allow the water flow. If the water flow backward, try to flow backward, the flap will be closed. So the water won't be hammered back to your system. That will damage your pump too. Okay. So if you talk about a very high up building, like a multi-levels building, the water pressure that will backflow into the system is actually very high. Okay, so it potentially damage your pumps. Okay, back to here again. Okay, we have a check WAF done. Of course, if you want to do any services, then you need to have a gate WAF. Okay, gate WAF. Another gate WAF again. PA for your gate WAF. Of course, you need to access to 150 mm gate WAF. Okay, another gate WAF over here. So you can turn your gate WAF. So how to model it? Of course, you can learn it from my course here again. Step by step, I'll show you how to model the gate WAF from a blank sheet of paper workspace. Okay, so it's done. This is basic assembly of my pump here. Go back to the 3D. You can see here. So the basic components all we have are gate valves in and out, a strainer for the incoming, and the flexible joints for both in and out going, and of course the backflow prevention, which is the check valve over here. Okay, so I guess that's all for this session. Thanks for joining.